Hey there, today we're looking at some very special binomial products. These are patterns that are going to repeat again and again. We have like 4 or 5 different special products of binomials that we want to look at. Let me show you the first one so you get an idea of what I'm talking about. What if we have a binomial, so let's say x plus 3, and we're going to multiply it by another binomial, x minus 3. What do we get, right? So the key here is that both of these binomials have the same 2 terms in them, but they have the opposite sign in the middle, okay? So when that happens, what is the pattern going to be? What kind of answer do we get? So let's do this, right? So we're going to use our foiling method. So we're going to multiply the first times the first, so that'll give us an x times an x, and then we're going to get the 2 outer terms, right? So x times a negative 3 plus x times a negative 3. And then we're going to multiply the 2 inner terms. That's a 3 times an x, 3 times an x. And then finally, we'll multiply the 2 last terms. So 3 times a negative 3. Just like that. And so this is going to be our first times first, outer times outer, inner times inner, last times last. This is how we FOIL, okay? Now let's simplify this. What do we get here? Well, this will become, this will become an x squared. This will become a minus 3x. This will be a plus 3x, and this will be a minus 9. And notice that the minus 3x and the plus 3x, well, they're going to cancel away, okay? And so that's always going to happen with this pattern. When you have 2 binomials like this, the same 2 terms but the opposite sign, the middle 2 terms here, the outer times the outer plus the inner times the inner, those are always going to cancel out, okay? And so what we're left with is, we're just going to say that this is going to be equal to x squared minus 9, okay? So let me show you the general rule for how this works. Going to look something like this. Okay, so what we're saying is that if you have any 2 binomials where you have an a plus b multiplied by an a minus b, right? So your same 2 terms, you're just switching that sign. You're going to get a squared minus b squared, right? That's what we got here. The first 2 terms here, at the x, we get an x squared. And then the last 2 terms of 9 is going to be a 3 squared, so that's 9, and it's going to be a minus 9. That's exactly what we got here, and that's always going to work when you follow this pattern, when you're taking the product of the sum and difference of the same terms. That's what we have here, the sum of x plus 3 and then the difference here, x minus 3. Let's try a few examples so you can sort of get the hang of what we're talking about here. Let's try doing 2x plus 7 multiplied by 2x minus 7. What is this going to give us? Well, if we follow this pattern, this is going to be a, this is b, right? This is a, this is b. So what we should get is 2x, this quantity squared, minus this 7 squared. And that's exactly what we're going to get. So we're going to get a 4x squared minus 49. And this is actually going to be our final answer for this practice problem here. Let's try one more. Okay, let's try one more. Let's do something a little bit more interesting. What if we have a 4x squared plus 5? And then we multiply this by a 4x squared minus 5. Okay, so once again, we're going to follow the same exact pattern. So this is our a. We have to square that. So we're going to get 16x to the 4th power. And then minus, well, 5 times 5 is 25. Okay, so there we go. That's how we can use this rule to multiply 2 binomials that follow this pattern of a plus b times an a minus b. All right, so let's go and look at the next special product we are going to look at. All right, here we're looking at the square of a sum. Okay, so that means we're going to have a binomial with sum a plus b, let's say x plus 3, and then we're going to just square it. Okay, so this is a very special pattern. You're just squaring a binomial expression. What do we get? Well, of course, this is the same as x plus 3 multiplied by x plus 3. And from here, we can just FOIL it, right? So if we FOIL this first times first, well, that's going to be x squared. outer times outer, that's going to be a 3x. Inner times inner, well, that's another 3x. And last times last, that'll give us a 3 times 3 is 9, right? So we did it right here. We did our FOIL. We did our foiling method, and we can simplify this, right? So when we simplify this, we're going to get this is all equal to x squared plus 6x plus 9. Just like that, okay? Not too bad. And so you can sort of start to see there's going to be a pattern that it's going to repeat. Anytime you square a binomial that's a sum, we're going to have a pattern. Here's sort of what the pattern is going to be. All right, so what we're saying is anytime you have some a plus b squared, you're going to get a squared plus 2ab plus b squared. And that's what we got here, right? So ab is just 3x, but we have two of them, okay? So we're actually going to get, in this case, 6x. 6x is just another way of saying 2 times 3x, right? The 2ab. So that's the pattern for the square of a sum, all right? It's going to be a very, very common thing because you're just taking some binomial and squaring it, right? Let's look at an example problem here. How about we take x cubed plus 4x and we square that, okay? So remember, this a and this b can be anything, okay? That can be anything at all. So if we follow this rule, what we're going to get is, well, we're going to get a squared, so that's x cubed squared, right? And then we're going to get a 2 times a times b. And then we're also going to get a b squared. So that's 4x quantity squared, just like that, okay? And now let's simplify what this is. X cubed squared, our exponent rules tells us we're going to have to multiply those exponents together. We will get an x to the 6th power. Here we're going to get, well, this becomes a 2 times a 4. That's going to be an 8. X cubed times x. We add the exponents, right? It says x to the 1st power. So this gives us x to the 4th power. And then finally here, 4x quantity squared will be 16x squared. And now this should be our final answer for the square of this sum, this binomial here. All right, so very, very handy pattern that can be used. Really, a and b can be anything, okay, and this will work. Now, there is actually an interesting way that we can think about what's going on here. Because we can actually think of this as kind of like taking the area of a square. Let me show you what I mean. All right, so if I draw a square here, what I'm going to say is the length of this side, I'm going to call the length of this side a plus b. Okay, so what I'm going to do is I'm going to say, let's say this first part here, this is length A and this is length B. So if I add them together, I get a side of length A plus B. Okay, that should be fine. And when you take this side of length A plus B and square it, what are you doing? You're going to get the area of this entire square, right? So to square that, you're going to have this side is length A plus B, but it's a square, right? So we're going to have also this side is length A plus B. And so let me just draw another line here like that, okay? So I hope you see what I'm saying here. A plus B squared, if we think of A and B as just some integer or some natural number, then that's just going to be a length of whatever, length C essentially, right? This entire thing is of length C, and we're taking C squared, so we're going to get the area of this square. But C is A plus B, so we can break it down that way. And what we get then is we're going to get 4 different sections within this square. So each one will have its own area, right? You're going to have the area of this square in here. What's the area there? Well, it's going to be, this is length A, and this is length A, so this square will be length A squared, right, won't it? So this is A squared. Likewise, this square here will be side length B times B. So this square will be of length B squared, of area B squared. And then we have these 2 rectangles here, but each of these is going to be of length A times B, right? So this will be AB, and this will also be AB. And so what is the total area here? Well, the total area must be then A squared plus AB plus AB plus B squared. And of course, this simplifies down to this formula right here. So you can understand the square of a sum, this rule, this property here, as essentially literally getting the area of a square where each side is of length a plus b. And that's just geometrically what's going to sort of happen. So we can do this either by foiling or by geometrically thinking about a square and finding the area there. All right, so let's take a look at another related pattern to this one. All right, here we're looking at the square of a difference. What does that mean? Well, before we did the square of a sum. So a square of a difference would be something like x minus 3 squared. Okay, very similar pattern. It's just that we have a negative sign here now instead of a positive sign. So instead of a sum, we have a difference. All right, so what do we get here? Well, we can, of course, look at this as x minus 3 times x minus 3. And if we do this, we can FOIL, right? So first times first, well, that's going to be an x squared. Outer times outer, well, that'll give us a minus 3x. Inner times inner, another minus 3x. And last times last, well, that's going to give us a negative 3 times a negative 3. That's a plus 9, isn't it, right? Okay, so here we go. This is our FOIL. We FOILed these two binomials together. And of course, this is going to simplify, isn't it? Okay, so let's copy this down here. This will simplify to x squared minus 6x plus 9. Okay, so what's the rule? What did we actually do here? Here's the rule. This is what we did. We have some a minus b, right? And we're going to get this a squared minus 2ab plus b squared. Okay, that's exactly what we got here. Okay, so we have a positive sign here because this is a negative squared. So we're going to wind up with a negative 3 times a negative 3. That will give us a positive 9. And then we have this negative sign here because we are multiplying negative 3 times x and x times negative 3. So these are both negative, right? And so when you add them together, you're going to get something that's even more negative. So that sort of explains where the signs come from here. So you can see that this is very similar to what we had before. It's just that when you have the sum of a difference, you have square of a sum, this is a positive sign. When you have a square of a difference, it's a negative sign. Okay, so you can either just remember that, or there's another way to think about this, and that is to actually don't think of this as a separate formula. Instead, you can think of this as some kind of a plus a negative b quantity squared. Okay, so if you think about it this way, it's actually just using the previous formula, the square of a sum. You're just thinking of this as an a, and this term as a negative b, and you're adding them together. This means that previously we would get some kind of a squared plus 2a times this second term is a negative b, and then we get this plus this negative b squared. Okay, and this will actually work because this will simplify to a squared minus 2ab plus b squared, which is exactly what we're getting here. Okay, so this is an alternate way of thinking about this. You can imagine this is not a separate formula. It's just the first one, and we're adding a negative, right? We're adding this negative term there. You can rederive this formula if you need to. All right, so let's look at an example. So previously we did x cubed plus 4x. So let's do a minus 4x and square all of that. Okay, so what will we get? Well, let's just follow the rule here. Okay, so this is our a. So we're going to get this a squared minus 2. What do we have next? Well, it's minus 2x cubed times a 4x. And then we're going to get a plus 4x quantity squared. Let's simplify. This will become an x to the 6th power. This will be a minus 8x to the 4th power. And this will become a plus 16x squared. There we go. That should be our final answer for the square of a difference for this binomial right over there. All right, so let's take a look at another special binomial product. All right, so now we're looking at the cube of a sum. What does that mean? We're going to have a binomial. Let's just say a plus b, and then we're going to cube it. Okay, so the cube of a sum instead of the square of a sum that we did earlier. So we're going to a higher power now. Okay, this is going to give us more terms when we cube this, but it's actually not too bad. I'm going to take this a plus b cubed and try and derive the formula that this is going to equal, and I'm going to take it apart. I'm going to rip this apart, and I'm going to make this into an a plus b multiplied by an a plus b quantity squared. Okay, these are going to be equivalent. And I did that because now I can say this is some a plus b, and I know what this is. A plus b squared, I know this is a squared plus 2ab plus b squared, right? This is the square of a sum. So we already did that. We already know that process and that formula. So what do we do here? Well, just like before, you could sort of think of this entire thing as like one term, right? You call this x, and then you'll have sort of ax plus bx, right? You just sort of distribute that x into here. So essentially, that's what we're going to do, okay? We're going to then take this and say this is equal to a times all of this, right? Plus b times all of that. Okay, you see what we did? So we sort of took this term and we distributed it into the a plus b. So we get a times all of this plus b times all of that. Okay, that's what we get here. Now, let us see what we get. I'm going to now distribute this a into the parentheses here, and then I'll distribute the b as well. So on top, we're going to get a times a squared, that's a cubed, plus 2a squared b plus ab squared. Okay, that's what we get for this top part. And then on the bottom, I'm going to distribute the b into this parenthesis. So I'm going to get a squared times b. Well, that's just a squared b. And notice I'm lining it up. Okay, so we sort of have these like terms all lined up in the same column. Okay, so that's what we get here when we do b times a squared, right? Next, we're going to do this here, multiply the b there. We're going to get a plus 2ab squared, right? These line up, like terms. And then finally, b times b squared is going to be a b cubed. And since all of this is added together, let's just do polynomial addition and add it together, right? What are we going to get? Well, we're going to get, in this case, a cubed plus, looks like this is 2a squared b plus 1a squared b. That's going to be 3a squared b plus, well, it's the same thing, 1ab squared plus 2ab squared. That'll be 3ab squared. And then we have a final b cubed. This then is actually the formula for what we get here. Now, this formula looks a little bit confusing, but if you notice the pattern, you'll be able to remember it. Okay, so first, when we did our a plus b squared, this square of a sum, we had this pattern of coefficients. This is 1, this is a 2, and this is a 1. Okay, so that's kind of easy to remember. Here, the pattern is 1, 3, 3, 1. Okay, so if you remember that pattern, you're going to be good, and we will learn sort of where this pattern comes from in a different way in the future, where we'll learn even more patterns. But this 1, 3, 3, 1 is a pattern that you should be able to remember. And then when we write everything in standard form like this, you sort of start out with an a cubed, and then you go down to an a squared, then you go down to an a to the first power, and then you go down to an a to the 0, which is just 1, right? So you can think of the powers here starting at 3, just going from 3, 2, 1, 0. And the b's, they go in the opposite direction, right? Here we end with a 3, then a 2, then a 1, and then this is b to the 0 power, right? So that's sort of the way that you can try and see the pattern in this rule, okay? The b's go from 0 to 3, the a's go from 3 to 0, and then the coefficients are of this power of 1, 3, 3, 1, that kind of pattern there. Okay, so that's the idea, right? If we were to just write the rule down, we'll get something like this, right? So here's our rule. Well, I guess I'll put it here. Oh, maybe I'll put it there. Okay, so that's the rule for the cube of a sum. Now, you could also visualize this geometrically, just how we visualized this square of a sum as taking like the area of a square. You can visualize the cube of a sum as taking the volume of a cube. Okay, now this is a little bit more difficult to draw, so I might not do a great job here, but the idea is if you have a cube, okay, so let me try and draw a cube. Okay, so let's say this is our cube. Something like this. Okay, so here's a cube, okay? And the idea is this each length of each edge here is going to be some a plus b, right? So let's call this some a plus b, right? So let's say that just like before, a is longer than b, right? So we can have that here, and you can sort of extend this around like that, right? So this will be our a plus b. And then you can look at the other sides, okay? So let's look at this side over here. Let's say that this is our a plus b. So we'll draw another line like this, right? So that'll be some a plus b. And then finally, you can look at the top side here. Let's say this is our a and b. So let's draw it sort of like this. Something like that. Okay, so what we're going to see is you've taken this single large cube, and this single large cube will have a volume of, well, this is, each side is length a plus b, so the volume of the cube will be a plus b cubed. This is the volume of the cube. And if you notice, this single large cube is actually going to be divided into many sections, each with its own volume. How many sections? Well, it's actually going to be divided into eight sections, right? So if you then try and find the volume for each of these 8 sections, you're going to actually rederive this equation that we just got there. So let me sort of show you how this kind of works. We look at this corner piece right here. This corner piece is going to have here a side length of b, a side length of b, and a side length of b. So the volume here must be b cubed. Okay, that's going to be our b cubed term that we get right here. Likewise, on the opposing corner over here, this is going to be side length a, this is side length a, and it's going to be going down here a length a as well. And so this is going to give us a volume of a cubed, okay? So that gives us 2 of the sections. So there's going to be 6 sections remaining, and it turns out that 3 of those sections are going to be the same, and the other 3 are going to be the same, right? So let's look at one of them. So let's look at this one. This is length a, this is length a, and it goes back a length b. So the volume of this piece here is going to be a squared b. And it turns out we're going to have 3 of these. So that's where we get these 3 chunks of volume a squared b. And then if we look at this chunk on the bottom here, right, this one is going to have here, this is a length b, this is a length a, and then we're going to have another length b over here. And so this volume here becomes a b squared. So that's where this comes from. We're going to have 3 of those pieces. So all together we get 3 of these plus 3 of these plus 1 of these and 1 of these. That adds up to a total of 8 sections. So geometrically, you can interpret this formula for the cube of a sum as essentially taking the volume of a cube where each side is of length a plus b. Okay, so that's the geometric interpretation here. It can be a little hard to see, but it does actually work out. All right, we've got one more special product we want to look at. And the last special product is a cube of a difference. So this is going to be something like an a minus b quantity cubed. And just like before, we can work this out. We can separate this cube into an a minus b multiplied by an a minus b squared. And we know what the formula for that will be. That's going to be an a squared minus 2ab plus b squared. And just like before, we can essentially take this and distribute it in here. And so we're going to wind up with a multiplied by all of this. And then we're going to get here a minus b multiplied by all of this, okay? And now what we can do is we can distribute the a into this parentheses, and so we're going to get an a cubed minus 2a squared b plus ab squared. And then we will distribute this b in here, but this is a negative b, okay? So let's make sure we keep the signs correct. So this is a negative b times an a squared, okay? So that will give us a minus a squared b. And then we do the same thing here. So this will become a plus 2ab squared. And then finally, a negative b times a positive b squared will be a negative b cubed, okay? And so now we've got that. We can add these two polynomials together, polynomial addition. We are going to get here an a cubed. Here we'll get a minus 3a squared b. Here we'll get a plus 3ab squared, and then a minus b cubed. There we go. That's going to be the formula that we use for the cube of a difference, just like that. And notice it is very similar to this cube of a sum. The only change is these used to be positive signs, right? The cube of a sum, everything was positive here, but for a difference, you get a negative sign, and it kind of alternates, right? We get a positive here, then a negative. A positive here, then a negative, okay? And so that's what we are actually going to expect to happen when you have this kind of difference, right? How can we remember this another way? Well, another way we can treat this is as the cube of a sum, right? We can use the cube of a sum formula, but just like we did with the square of a difference, we're going to look at this as like a plus negative b cubed, okay? So if we treat this as adding a negative b, then when we look at our formula, we should actually get now a cubed plus 3a squared times negative b, right? Plus 3a times negative b squared plus negative b cubed, okay? And so this is actually the same formula as the cube of a sum. We're just treating this term as a negative b and plugging that in. And so that way you actually don't have to remember a separate formula here for cube of a difference, although you can. And of course, you can sort of see now where these negative signs actually come from. They come from the fact that if you simplify this, we're going to get a cubed, but here, because this negative b is raised to the first power, it stays negative, right? And so when we simplify this, we get minus 3a squared b. And then here, this negative b is raised to the second power, and so the negative sign, that disappears, right? We only get a positive value here. We're going to get plus 3ab squared, and now we have negative b cubed, and so that will actually be negative, right? So this will have a negative b cubed, and notice that this is going to be exactly the same formula as we have there. So you can rederive the cube of a difference if you remember the cube of a sum, and just treat this as a negative b, essentially, okay? Okay, so there we go. Hopefully this helped out learning about these special binomial products, right? We learned 5 of them. The first one was the product of the sum and difference of the same terms. Then we had the square of a sum, square of a difference, cube of a sum, and cube of a difference, okay? The square formulas, they're going to be a little bit more useful, a little bit more common, but it's good to remember all of them. All right, so come back next time when we start looking at factoring polynomials. I'll see you then.